Hi, today we're going to get a quick introduction to balancing equations. This video is fairly short for an equation balancing video. If you want more intense instruction, I've dropped a link to my visual chemistry episodes for balancing equations down below in the description. Let's get started. First of all, let's take a look at what we see in a chemical equation. Basically, it's a shorthand method for showing what molecules are involved in a reaction and how many of each molecule you have. So here's an example of a chemical equation. Here, if you look at the green stuff, it's telling us that we have carbon and oxygen combining to form carbon monoxide. And specifically, everything on the left half of the equation is what we call reactants, the things that are combining in this chemical reaction, and everything on the right side is products, the things that are produced by this chemical reaction. You'll also notice there are some numbers, and these tell us about ratios. Here, carbon combines with oxygen in a 2-to-1 ratio. You'll notice there's no number in front of oxygen. That's because there's only one, so we don't put a number. If there's just one, that's just assumed. So carbon is combining with oxygen in a 2-to-1 ratio to produce 2 molecules of carbon monoxide. So there's twice as much carbon monoxide as oxygen. There's the same amount of carbon monoxide as there is carbon. The reason it's important to have what we call a balanced chemical equation is because of this law that we call the conservation of matter, which quite simply states that matter cannot be created or destroyed. And of course, I've got to throw an asterisk in here. That's what usually happens. It is possible to create or destroy matter, but it's very hard and energy intensive. So the majority of matter here on Earth is not going to be created or destroyed. And when we talk about chemical reactions, we're basically talking about shuffling matter around, not making new matter or getting rid of old matter. For example, if you look at this equation where we have carbon and oxygen making carbon dioxide, is matter created or destroyed? Well, we can kind of look at this pictorially. So here we have a carbon atom and we have an O2 molecule, and you can see everything in the molecules on the reactant side combine to form the product. There's nothing left over, and you don't have to throw in any extra atoms. So matter's not created or destroyed. Let's look now at another chemical reaction, the combination of hydrogen and oxygen to form water. We're basically taking oxygen gas, O2, and we're going to move it over to our product side, and then we're going to take our hydrogen gas, H2, and we're going to move these over, and that makes one molecule of H2O, but there's this other oxygen that doesn't appear in the chemical reaction. So where does that go to? And this is what I mean when I ask, is matter created or destroyed? Well, matter can't be created or destroyed. Something else will have to go on. And so we'll come back to this in a little bit, but what I want to do first is talk to you about what I call the sandwich equation. So we're going to do a simple sandwich equation here. We're going to make a cheese sandwich with nothing but 2 slices of bread and 1 slice of cheese. 2 slices of bread plus 1 slice of cheese is 1 sandwich. Now, if you want to make a sandwich and you don't have anything at home, you're going to have to get bread and cheese from the store. But you can't go in and say, hey, I'd like 2 slices of bread and 1 slice of cheese. That's not how it works. Bread comes in loaves. Sliced cheese comes in packages. And you're going to have to buy them in the packages they come in. So let's imagine now that you're going to make cheese sandwiches, and what you need to do is buy enough packages of cheese and enough loaves of bread that you make an exact number of sandwiches, but also use up everything that you bought. So you can't have any leftover bread and you can't have any leftover cheese. So if there are 20 slices of bread in a loaf of bread and 12 slices of cheese in a package of cheese, how many loaves of bread and how many packages of cheese would you need to buy? Now, I'm not going to give you the answer to that question. It's going to be one of your reading questions, but I want you to think about that and do the math and get back to me. But this is basically what we're doing when we balance an equation. We're saying, okay, we have this equation that tells us how we're going to create some sort of product, like our cheese sandwich, and we need to buy a certain number of packages of our ingredients, which are our reactants, and we have to use up all of those packages, because if we don't, stuff is left over. So let's take that approach and let's apply it to hydrogen and oxygen. So again, when we moved our oxygens over to the product side of the reaction and we moved our hydrogens over, we're left with an oxygen. And so what we have to ask ourselves is, what should happen to that oxygen? That oxygen should make a package of water, if you want to think of it that way. A package of water is one oxygen and two hydrogens. This oxygen right here does not have any hydrogens. It needs hydrogens. So let's add hydrogens, and we'll indicate that we are getting a second package of hydrogen by writing a 2 in front of the hydrogen in our balanced equation. So now we can move those hydrogens over. At the end, we have 2 water molecules. So obviously we're not going to be drawing pictures every time we do this, although you could. And in fact, if you look at my visual chemistry series, I essentially do just that. But there is an easier way to do that, which is to come up with a table in which you're going to keep track of each element and how many atoms of each element you have, both in the reactant side and the product side. And what we're looking for is to have an equal number of atoms of a particular element in the reactants and in the products. If you have the same number, that tells you that atoms of that element are not being created or destroyed. So in this particular case, we have 1 molecule of hydrogen with 2 atoms of hydrogen each. We have 1 molecule of oxygen, which is basically a package of oxygen with 2 atoms of oxygen inside. And we're making 1 molecule of water, 1 package of water with 2 hydrogens and an oxygen. Now, if you compare these, you see that we have the same number of hydrogens in both the reactants and the products, but we seem to have fewer atoms of oxygen in our products. So what we're going to do is we're going to go back and we're going to look at our reaction, and we're going to look for a place in our products that contains oxygen so we can add more of that, because when we add more of that, we're going to get extra atoms of oxygen. So water has oxygen in it. I mean, that's pretty easy. It is our only product, but we're just saying, this is what we need to do. So we need 1 atom of oxygen. That means we'll need 1 molecule of water, since each molecule of water has 1 atom of oxygen in it. So let's make that 2 molecules of water, and then we're going to write in 2 extra hydrogens and 1 extra oxygen down below in the products column. Now let's compare what we've got. You can see we have the same number of oxygen atoms, but now we're missing hydrogens here. We have 4 in the products, we have 2 in the reactants, so we basically need another package of hydrogen atoms to make this balanced. So let's throw in a 2 there. Now we have 2 times 2, so we have 4 total hydrogen atoms on the reactant side, and now you can see we have the same number of atoms for both of our elements. This is a balanced reaction. So here's another reaction for us to balance. Let's go ahead and draw up our chart. Here we have different elements. We have nitrogen, oxygen, and hydrogen. And you'll see our first reactant is N2O5. So we're going to have 2 nitrogens and 5 oxygens. And then we're combining that with H2O. So we're going to have 2 hydrogens and 1 oxygen from that. And our product, we just have 1, is going to be HNO3. So 1 H, 1 N, and 3 oxygens. So if we compare these to each other, you can see that we have fewer atoms of every single element in our product side. So let's just choose one. Let's say nitrogen. We have 1 nitrogen. We need 2 nitrogens. So basically, we're going to double the number of packages we have. So now we're going to add in another hydrogen, another nitrogen, and another oxygen. And you can see that now we have the same number of atoms of nitrogen, oxygen, and hydrogen in both reactants and products sides. So that is a balanced equation. So here's another equation. This one is for the combustion of methane. which is basically the burning of natural gas, which some of you may actually get to do on a daily basis in your homes. This one is different from the previous equations we balanced in that it has two products instead of one, so it's going to be slightly more complicated. So again, we're going to start off with our table. We have carbon, hydrogen, and oxygen. Our first reactant is methane. That's 1 carbon and 4 hydrogens. And then our next reactant is oxygen gas, and that has 2 oxygens. And then on our product side, we have carbon dioxide, which is 1 carbon and 2 oxygens, and hydrogen, which is 2 hydrogens and an oxygen. Now you'll notice that we have 2 elements that have different numbers of atoms in the reactants of the product. So we have hydrogen and oxygen. And you'll notice I'm always circling the side that has fewer atoms, and the reason I do that is because we can add atoms by finding packages of something or another, but we can't subtract them. We can't take things away. So I've circled hydrogen and oxygen. So if you look at hydrogen first, hydrogen has 4 atoms in the reactant side and 2 in the product side. We need more products with hydrogen. We only have 1 molecule that has hydrogen in it, and so we need more of that. We need to go from 2 to 4, so that tells us we need 2 molecules of water. So let's add an extra molecule of water in there. That would give us 2 more hydrogens and 1 more oxygen. And now let's look at oxygen, which is the one thing we haven't reconciled. We have 2 in our reactants. We have 4 in our products. What do we have in our reactants that we can add to give us more oxygen atoms? Well, just oxygen. So we can add 1 more of those, giving us a total of 2. That will give us 2 more. And now you can see we have equal numbers of carbon, hydrogen, and oxygen. And so therefore, this is a balanced equation. So balancing equations is one way we ensure the conservation of matter. And balanced equations end up being really important in many of the things that we do in chemistry because they tell us the ratios in which things combine. And we'll talk about that in the next video. I do want to say, once again, if you want to see some more examples, go to my visual chemistry series. And even if you think you're good at balancing equations, check out video number 3 because I teach some tricks that really help people with crazy equations. I hope this was helpful, and I look forward to seeing you again soon.